4.14 Function Notation Part 2. You are given the function h of t equals t squared plus 2t plus 1. Find h of t. So what's happening on a t chart is normally we'd have x on this side and y on this side, but we don't have any x's. So in place of our x's, we have t's. And then in place of the y, we have our function notation h of t. So what they're asking us to do is plug in a -2 for the independent variable and then find out what the dependent variable is. Remember, on this side, this is your independent variable. And on the other side, your y, or your function notation, that's your dependent variable. And that's a t. All right, so basically, all you need to do is just plug in wherever the t is, plug in a -2. So we have h of -2. So this just tells us what we're doing. We're plugging in a -2 in for our h function. And then over here, what's going to be the result? Well, when you plug in the -2, you're going to have to square that. And whatever you're plugging in, the whole thing is squared. So this means -2 times -2, which is a +4. And then +2 times -2, that's -4 plus 1. So +4 minus 4, that's just 0 plus 1, and that would just give us 1. 0 plus 1 is 1. So this is our answer here. What's happening is when you plug in a -2, you get out a 1. So could you write that as an ordered pair of -2, 1? Yes. Could you also write that in function notation? H of -2 equals 1. Yeah, so there's 3 different ways that you could write that little ordered pair. Right, for number 3, if t is dependent upon s, so t is the dependent variable. So if t is dependent upon s, and 2t plus 4s equals 3 minus 6s, rewrite the equation using function notation. Hint, always solve for the dependent variable first, then replace the dependent variable with function notation. Okay, so let's just rewrite this. Sometimes s's look like 5s, so I will put little lines at the end there, so you know those are s's. Okay, so we're going to be solving for t because that's the dependent variable. So here's our t, so we just need to get this term away from it. So to undo adding your 4s, we're just going to subtract that. Positive 4s minus 4s, that's 0. And then we get 2 times t equals, you know what, my t's are looking funny here. 2 times t equals 3, and then -6s minus 4s is a -10s. And then we just need to divide by 2 to both sides. So to undo multiplying by 2, we'll just divide by 2. And whatever you do to this side, you have to do to the entire side over here. Well, you do that to the entire side on both sides. Anyway, we're getting this here. This is our common denominator, so we'll put it under the 3. And we'll also put it under this term here, the -10s. And when you simplify that, you get 3/2, and then -10 divided by 2 is a -5s. Now you can put the term with the s, you can put that in front, just as long as you keep the negative, attach the negatives, or the subtraction sign, attach it to the 5. So you'd have -5s plus 3/2. Either way is fine. You can leave it like this, or you can write it like that. Now that we have the dependent variable solved for, we can replace it with function notation. So we'll just call this f of s. So your independent variable goes inside the parentheses, because that is your x variable. That's your independent variable. And we are done. with this problem. So f of s equals negative 5s plus 3/2. That's my funny looking s up there. All right, let's look at the last problem. Okay, suppose we have a function defined by f of x equals negative 3x plus 7. What value of x will give us f of x equals negative 17? So let's see what's happening on a t-chart. Now, when you're looking at function notation, whatever's inside the parenthesis, that is your x-coordinate, and we don't know what the x-coordinate is. And whatever is on the other side of your equal sign, that is your y-coordinate. So this is a little different. This time, we were given the y-coordinate, and now we need to find the x-coordinate. If you want, what you can do is you can put back in your y. Before we had the function notation, it was originally a y. So you can rewrite it as y equals negative 3x plus 7. And then say we're going to put negative 17 in there for that. Or you could just replace all of the f of x with the negative 17. Whatever works the best for you. But we're replacing the y with negative 17, and then we're going to solve for our x. And then to undo adding 7, we'll subtract 7 to both sides. That cancels to 0, and then we get, or subtracts to 0, negative 17 minus 7, that's just negative 24. And then how do we undo multiplying by negative 3? We'll divide by negative 3. Negative 3 divided by negative 3 is 1, positive 1. And then we're left with negative 24 divided by negative 3, that's positive 8. And then we just have x over on this side. So that means when our y-coordinate is negative 17, our x-coordinate is 8. Let me put that in there. So you can write that 8 comma negative 17. That's a little point or dot on your graph. This is actually a line. Or you can write it f of 8 equals negative 17. And they just said what values of x will give you a result of negative 17. So they just want you to say x is 8. That's your answer. But I like to write it like this. That's what I prefer.